Well, I think we've got a quorum, so I think it's time to start here, okay? And we're going to do a little bit of introduction here. My name is John Emmer. I work for Rexel. And what we're covering today is a series, as a first in a series of webinars on deploying security on the plant floor and working mostly with Rockwell equipment, but with Cisco and Fortinet and a few other things are in here as well. And what I want you to gather out of this is a presentation which we'll send you at the end. There's quite a few slides in it. So it's not totally in depth in this presentation, but each of these following ones that are follow-up are going to be a little bit further in depth on each of these subjects. And you'll get an invitation for each of those. And what I'll also say is as we go through this, take what you see today. We'll send you a recording if you'd like to have it. And if you're an OT person, talk to the IT folks. If you're an IT person, talk to the OT folks. And it might be something to kind of look at together and say, let's take a look at these other ones, and here's some ideas and things we can look at and kind of go ahead with. So if you see some things you're interested in today, too, I'll also volunteer where we've got about 9 different sections we're running through. And we're going to do this in less than an hour. And each of those 9 sections, we could probably do an hour on independently too. So if you see some things and say that's a good idea, there's where we'd like to start. Give me a call. We'll go out and we can go through those in greater depth. And we've also got on the call here today. I won't bother introducing everybody in order to save some time. We've got some really good Rexel network engineers too that have great experience in the IT and the OT world both. So those people can also help out with this as well. So what today's subject is, developing a more secure plant. And we're going to talk about a little bit of technologies. And I want to point out as we go through this, some are very low cost. You already own them possibly. And there's others that definitely have a cost. They might change the way things are architected and how we go about the network security. So there's different costs in here, and I'll mention those. It's kind of low cost or low hanging fruit as we go along. But the principle is get started and do something, I guess. So today, here's what we're looking at. So we're going to look at some risks that exist on the plant floor, and we're going to talk about a little bit of standards that are out there. And again, there's going to be a bunch of those which I will send you the PowerPoint, and you can go find those on the internet and download those for yourself. There's lots of documentation that's out there that can be gathered from ISA and NIST and a few other places. We're going to talk about applying products and solutions, and that's kind of a precursor for the next session, which is in a couple of weeks. We're going to talk about some of the models of that have been produced by Cisco Rockwell of how to implement this for a secure environment or a sustainable environment. We're going to talk about asset inventory and a product we have that does vulnerability studies, which is a good place to start if nothing else is in here that's been accomplished yet. A little bit about patching, authentication. We talk about threat detection, secure communications, asset recovery and source code control, and authentication. So those are kind of the areas we're going to run through. And again, there's a lot of depth we can go through in each one of these. If we want to circle back and you want to give me a call, we can go through those as well. So understanding risk. I want to talk a little bit about what's different in a plant floor. So when you work with IT folks, they're typically interested on the right of things like protecting data and protecting information that comes into the company, those sort of things. On the left side, if you're an OT person, the difference is that the outcomes are very physical. We're moving machines and we're moving tasks like this. And with that becomes, a few different requirements. The same equipment works on both sides, but we're accomplishing different goals. So it's more safety focused on the OT side and more information and security focused on the right side of the plane. The neat thing is, though, if you can get together with the others, each side of the business, they're technologies that apply and can be used in both. What's the IoT risk? Loss of life, stolen intellectual property, production loss, unscheduled downtime, damaged equipment, environmental impact. We all know those exist, and if we lose a control system, any one of those things can happen, and it's something we would want to experience. So what do we typically have for an environment? And this is where we differ a lot in OT and operational technology from the information technology. In the information technology, we usually go through a lot of recycles. Most of us have laptops issued by a company that are hopefully not more than a couple years old. We have, very good change control on that. There's patches that are automatically updated. On the plant floor, we typically experience a lot of these things, like lack of visibility of what's going on out there. So we know that the plant's running. We really don't know what's happened on the network or what security flaws might be there and that sort of thing. We also have a lot of insecure designs. We didn't think about this stuff probably 10 years ago when things were put in, and definitely 15 or 20 years ago, we didn't think about it at all. So some of those designs that are out there are very insecure. We have a lot of antiquated systems. If anybody's on the OT side, I imagine everybody's probably got some Windows XP, Windows 11 computer that's running somewhere out there that hasn't been updated, and possibly can't be updated because the source code's gone, and we really can't restore it or recontrol it in the new system. So, all right, my mouse went to the wrong screen here. So I'm not going to go through a bunch of these. So, but I did want to throw up a screen if you want to look these up. And these are actually malware that's happened in the OT environment. And this all started, probably the first one we all heard of was Stuxnet over on the left. And there's been a bunch of them that have occurred. And what's happening today is that a lot of the hacker community and the bad people on that side have actually started looking at OT systems because they know they're old, they know they're full of holes. And they can either attack the OT side and, through ransomware, those sort of things. And they can also, a lot of times, use that as a vector to get into the IT side of the business. There's been examples of that that's happened. This one kind of stops in 2017. I was actually looking up, I didn't update my slide here, but there's, half a dozen more that have happened in the last couple of years. And one of the worst one, which, I won't cover in too much detail, is in Saudi Arabia, there's actually an attack on the safety systems of a chemical plant, of actually their oil production. And if anybody's in the process business, they know that a safety system is kind of there to make sure the plant doesn't blow up. And there's an attack on that, and there's some vulnerabilities there that have been exploited there and other places, which is that's a scary process. That's one out to do damage, for example. So interesting picture here. And this one really kind of visualizes, I like the chart on the right. There's a data breach investigative report. And if you want to find that, just search for that name on the internet, and you can download about a 40 or 50 page copy of this. And what I did is I highlighted some things that were in the manufacturing business end of that. So this is 2004. There's 2,305 incidents that have happened. The top patterns are system intrusion, social engineering, and miscellaneous errors, 83% breaches. So we won't go through all that. But the neat thing is, if you look at this chart on the right side over there, the trends, you notice that social engineering was the big way of doing this up till about 2022, and now it's system intrusion. So what that tells us is that the hacker community has, given up on a Stuxnet type approach where we'll grab some credentials. That still occurs quite often, but they're actually going after the systems, the routers, and the communication equipment that's in there now too for system intrusions. So there's been a big change in what's happening. Which is, definitely shows that it's becoming a bigger target. Okay, so what threat actors are out there? And what I want to point this out briefly is There's a lot of them. And we always worry about, is it a nation state? Is it North Korea that's hacking us? And I know I can't offend anybody there because there's probably no North Koreans here in this country right now. But so, is it one of those countries, or is it, something smaller? And what we find is the number one, source of attacks is within companies. And I will usually divide that into two things. I've been in the control industry for a very long time and see many instances, particularly when Ethernet was rolled out 20 years ago or 15 years ago, of a lot of accidental things that happen. So when somebody is looking at a network, they say, what's this IP address? So I'm going to tweak it and see what's happening. Or a control engineer says, what are these devices doing on my network? Because it's not segmented well, and I'm going to try to configure them or do things with that. Or just employees not quite knowing which is the right controller to be working on, and they're actually, instead of 345A, they're in 345B, those kind of numbering schemes, and they're in the wrong location. Also, revenge employees. There's a lot of instances of that where happy campers aren't leaving, and they're leaving holes in the system where they can get back in and cause some damage. And there's been lots of examples of those that have appeared too. So those are things that we don't think about as much as protecting about. We think about the outside hackers, but there's a lot of things through good network design and security also keep us safe on the inside. So what I'm going to do is briefly run through this, where those security holes might come from is a network. We all know we can be connected to that. They can be mobile devices. We have mobile devices connected to the internet. We have wireless. We might have a connection through that. And one thing I want to point out is I hear this almost, every 5 days that we're air gapped and we have nothing to worry about. And the safety system, one I just mentioned, was actually one that is typically would be applied in an air gap system where it gets in and actually creates connections to the outside world in order to let it have access. So even though we don't think we have physical access, if we have USB cards, if we have laptops that we use in two worlds and we're connected to the internet, we're never air gapped because there's definitely threat vectors could get in through those that way. Okay, so as we look at a drawing, we see direct attacks through the IT world, and that's why we need some good DMZ zones or good routers and devices between those. We see sneaker attacks within the plant, and like I say, in my years of going through issues with customers, I've seen a lot of them where they're just accidental. We've got we hired 32 contractors. They really don't know the names of all the devices, and they think they're uploading a program. They upload it to the wrong device. Those sort of things. So those are things that security also takes care of if implemented correctly. It keeps the wrong people out of the wrong devices too. So those are all possible items. And insider attacks, we see sometimes from the IT network, the OT world. And again, sometimes those are accidental. They're just curious about what's out there. Sometimes those could be, definitely a ill intent too, as well. So what we're going to talk about as we go through this, a little bit of a kind of a proactive approach on what to do before, what to do during, and what after. And this kind of fits into the NIST framework of security. And I'll throw some links out there where you can download information on what to start on that. But what they all are is items that you might have that you really don't have to purchase anything to apply. And there are things that you can purchase either through equipment, services, or whatever else as we go kind of across this chart. So we're going to start on the left side. We've got asset inventory services, and the best place to start with security is, do we know what's in our plan? If I was going to secure my home, which everybody's experience is to probably have 20 devices connected to the internet with TVs and everything else, I'd like to know what I have first, and that would require an inventory of what's out there. And then as we get that inventory, what do we need to patch? What's out there that isn't up to snuff? Either it's through firmware, or it's for Microsoft patches, those sort of things. And we can determine that sort of thing and the risk assessment of what's out there. And those are all places we're going to start, and we're going to talk a little bit about how we get going on that to begin with. So as we look at this, um, what we're trying to understand is what threat vectors are there. Is it threats to the OT? Is it the IT world? And what skill level it takes in order to get through there. And everything you put in security-wise is an addition to security that makes this guy, possibly go to the next company. So, hey, my tool that I thought I could get in there doesn't work. I'll go to the next company over. So everything we do is additive. It's a neat thing. We don't waste our money or our time on anything that we add to security in the OT environment. So associated standards, here's a list. And I won't run through those all, but one of them is IEC 62443 that essentially tells you how in a plant, suggestions wise of how to secure items for zero trust, for example, for the OT world, Internet of Things, and those sort of things. And these are kind of overriding documents, which you can download these from the internet, and you'll have lots of information that kind of goes forward and helps you get started on this sort of business. So generally what these standards deliver is common language, standard methodologies, and a guidance to answer what's my current risk. So am I currently at risk, and what do I have to do to get that to an acceptable level? So one thing that we use a lot is National Institute of Safety Standards, NIST, and that kind of goes back to that slide I showed earlier. And the kind of the phases of that are being able to identify what my threats are, how am I going to protect against those, and how, as I move across that spectrum, detect them, and how I respond and how I recover. So when you look at a lot of these, things that happen, they're particularly, malware that happens in a plant, I need to be able to recover is the big thing. So I can, start over my machine, have it run. I don't lose the program, and I can get things back to where they operate. Okay, so I'm going to skip over this. This is some of the documents that are out there for those. So, rather than read through the documents, so each of those policies, there's also a lot of documentation there, which you'll get the PowerPoint and you can go out and find this. So the only thing I'll mention is that, when we look at this, we can essentially achieve different levels. If I'm not too worried about security, and I don't think my plant produces anything of really high value and I can lose and whatnot, so I might just protect against the casual incident by unauthorized entities. If I have something that's very dangerous and I need to worry about those sort of things, I can go up to different levels of security and tie those in as all. And these documents kind of provide information on what it takes to get to one of those. So the first thing, like I said, to start with, before I'd start anything in security of my plant, I'd have to know what's in there and a little bit about the vulnerabilities that exist in those. So let's just say, it's usually kind of staggering, even somebody that doesn't think they have a lot of devices might have 60, 80 devices. You could have 300 out there connected on the internet. Those are HMIs, drives, historians, if you're in the process world, they're all the information that is going through SQL databases and all those sort of things. So I would first of all like to address that and see what my inventory is and what's the risk associated with each of those devices out there. And what you'll find is there's a vulnerability report for every device used in the OT world, whether it's Rockwell, whether it's Siemens, whether it's Anderson Hauser, whatever devices are connected out there. And it would be quite a task if I had to go out and inventory those by hand, create a spreadsheet and look those up. And I would probably be forever going back and trying to do that because I might have replaced 2 devices that had old information on it. So what we have is a service. And just to give you an idea of this, the cost of this is about $5,500 for any size plant, and we don't care how many devices you have. And what we can do is come out and run a software package that will go out and inventory every device in the plant connected to an Ethernet. And what that will tell you is it'll tell you the protocols that are out there, whether it's Modbus, what type of protocol, whether it's Rockwell or whether it's Siemens or whatever's out there. It'll find devices like managed switches. It'll find all the computers, the installed software, the vulnerabilities that exist if it hasn't been patched, for example, Windows, for example, and produce a report. And it'll tell me all my assets and where those issues might be, and tie those back to common vulnerabilities and exposures. So if I have an Ethernet card, for example, in a PLC, it will tell me that there's 6 or 7 vulnerabilities of which I can determine, do I need to upgrade that card? Is it something I need to worry about? Is it exposed to places that can get to it, and that sort of thing? So this would be the first thing, is I can do an asset inventory, vulnerability assessment. And once I have that list, I can work with my OT and IT teams to figure out how we're going to protect against that and leave things in place. And what we'll find is sometimes these vulnerabilities might exist in some equipment that's 15 years old that is never probably going to get patched. We just need to find a way to isolate that and keep that out of the rest of the plant environment, for example. So essentially, the vulnerability discovery produces a report, and it's about usually 40, 50 pages of a spreadsheet that tells me everything that's out there by count, and each of the vulnerabilities are listed and detected through there, and produces a map of communications of what's going on. So we can see over here, there's Cisco, there's Fisher controllers, there's GE equipment, so like all these types of devices or vendors. There's the top 10, and it will again show me the vulnerabilities that exist and everything out there. Any questions? If you do, raise your hand, and we'll keep an eye on that and get a chance to answer those. Okay, so applying products and solutions. If you look on, for example, the Cisco website or the Rockwell website, there's very good documents of how to architect a system that supports a lot of these security measures. And there's some that are on security, for example, but a lot of them are just good architecture in place that actually allow me to utilize the proper methods to implement the system. So when we could actually look at this, we see the word convergence a lot in the IT/OT world, and it kind of means a convergence of technologies. So a lot of the protocols, things we use in the OT world for controllers, or things we use in the IT world, same devices work. And I'll just mention that one thing is that Rockwell uses SIP ODVA protocol, and it's 100% based on Ethernet standards. There's no proprietary things in there at all that require special switches or special devices out there. So, the beautiful thing is that the technology that works in the IT world works in the OT world there. But what I would suggest is finding a OT-IT partnership and really kind of work through this and educate each other and work together. To probably implement everything that's in the OT world, you probably need things like domain servers and access to those type of devices, which are usually controlled by the IT world. But when you can work together and kind of produce this methodology and say, here's what we're trying to accomplish, it's a great path to go to kind of move ahead. So what I'd suggest is, no matter what side of the business you're on, take this presentation, and there's going to be about 6 more of these that are on more in-depth subjects, and get a partner and maybe look through this and say, here's some things I think we need to take a look at and what we could do. And again, we can do these through webinars, or we can definitely come out and talk to you in person about how to do these things as well. So when you look at this, defense in depth, these architectures that are co-developed by Rockwell and Cisco, and some of these are 270 pages long, so I'm not going to run through all the details, but they generally kind of lay out in a plant floor how these devices should be architected and what devices should be in place to produce a reliable, highly productive and secure environment. So when we look at this, the thing I wanted to mention here is there's items here that can happen on the OT side, and there's stuff that happens on the OT side, in IT side of the business. And there's where that collaboration needs to take place. And what I've seen in the past, and it's starting to change a lot, is that there was kind of this idea, well, we can't do it on the IT side. We don't know we don't want to talk to them. So vice versa the other way. So they didn't tend to talk. And a lot of these things just didn't happen because of that. But when we collaborate together and can see the needs for these items, then that architecture becomes a lot better, better designed. So when we start with that, one thing that we look at, and I'm going to kind of bring this back a little bit, is that a lot of plants are laid out in a very flat environment. So we have all our devices, they're on one Ethernet, we can see them all. And one thing that helps a lot with security, and internally it helps a lot because it keeps things from happening accidentally between cells, work areas, and whatnot, is to isolate those through what we call segmentation. And we have a seminar coming up where there's a partner we have, Fortinet, for example, that has a device that can sit on each of these cells, for example. And there's others out here too, which I didn't bother to put a name in for, but we'll segment that out and only allow the traffic that's destined for that device to be there. We'll talk a little bit more about that in a second. But what it generally does is keeps traffic away from devices that shouldn't see it and produces some secure environments where we can be local to a specific device or specific subnet as well. Okay, so we have a session on that, that proper design. It's going to be 6/19, and you'll get an email and invitation. So it's going to be presented by Warren Lennox of Rockwell Automation, and we're going to go through that, what it takes to put together that secure architecture with DMZ zones and whatnot, and kind of demystify that whole big document. So that's kind of coming up too, and something you can look at going ahead. Okay, patching. I know this doesn't happen much. When you look at things on the plant floor, they were patched when they were put in, maybe. So with that said, we all know that we should keep our systems up to date and proper patching. And the only thing I'm going to mention for that is that that's actually a program that should exist and be in place. And I'm going to use Rockwell, for example, is you can't patch OT systems particularly this, we're talking about the Microsoft world, with the latest and greatest patches all the time, because they tend to break things that happen in the OT world. And there's been some examples of that have happened in the past. So what they go through for example, Rockwell is a testing procedure. And you can look at these patches all the time and determine what should be installed. If you sign up for your My Support, you'll have access to these documents. And you can, kind of bring that into your patching routine and make sure that it's all been tested and whatnot. But this is all important, and something that's overlooked is patching of systems that's out there. And like I say, I think in probably 70% of the plants, it's just not done because it requires a little bit extra work and effort. Okay, something that you have that's built into your systems that I will mention here. This is another low-cost addition, is factory talk security. And normally, we're going to talk about a little bit about asset center. It's put in at the same time asset centers there, but it's built in. And what it does is allows me to essentially determine what should be able to happen on my network and what should talk. So when I call this up, and again, this is built in, it just needs a server to run on somewhere. I'm able to actually break it down and determine what should happen at HMI's example by operator. I can say who can configure software packages like links, like Transaction Manager, for example. And I have a security system that can be set up that way. I have a choice, and this is where the IT world comes in. Do I want this to be a directory which I maintain of users, or I can also tie that to the system domains of the company? And then I can enforce things like password aging and things like that would be automatically done by the company where you change your password all the time. So, we can secure controller tags to essentially go down and say who can read and write to those. because we all know that there's got to be a certain openness with the controllers where we got to be able to get the data, but we can actually control, what can be done in those and whether it can be read, written to, and who can do that as well. Also, an example is in the control logics world, we can go in and secure routines with a set of permissions. And if we create like for an example, an add-on instruction, those are usually something that's been tested. We really never want change because it could change everywhere in the plant. So we want to protect those and make those kind of invisible to change and do that sort of thing with it too. So that's something that's built in, and we can talk to you about how to get that done too. And we also have services which can help install that and get that running as well. Okay, next thing on the level up is we're going to have some more sessions on this. We're going to talk about intrusion detection and protection as well. So if we have a clean laid out system, we're segmented and everything like that, we have a lot of stuff we can work with. And essentially what threat detection platforms do, and we're going to mention there's really three that we commonly work with a lot. One is Cisco Cyber Vision, which allows us to go out and look for intrusion, look for things that are happening on the network. Another is Clarity, and the other is Fortinet with those devices I talked about, being able to, the FortiGate being able to separate out and segment a network. Those have that type of security built in too. And the security I'm talking about is being able to look at packets that occur in that environment and determine who should be talking to who. So if I have a cell down here that's, for example, let's say this one was a Siemens cell. This is a Rockwell one. And if I saw traffic coming between these cells that they shouldn't be talking together, a threat detection platform is able to flag that and say, here's something that hasn't happened before. There's something in this cell that's talking to another, and it shouldn't be. Or we've gone, from the IT world down to the OT world in a connection that hasn't been there before. We're able to flag those, or we're able to determine whether we want to prevent those types of intrusions as well. So I'll mention roughly, or first of all, the Clarity system. And each of these has advantages and capabilities that the others don't have. So there's pros and cons of each of them, but we'll just kind of start with one in lieu of time and kind of run through that. So what Clarity is a software-based system that it's actually part of that risk assessment. What we're doing, we're actually using part of their engine. Goes out and identifies the what's out there and what's located in the plant. It can detect threats that I just mentioned, things like protocol changes or items that don't typically talk together. It can protect by configuring these third-party devices. So Clarity works with Fortinet, for example, works with Cisco, and it's able to go in and change configurations and actually whitelist things that should be talking together, or we can choose to blacklist them and say those should never talk together. Let's go investigate that more. So those are all things that are done. So it also is able to look at zones and continually monitor, for example, of what's talking together, and we have a map of everything that's there. And if all of a sudden we see a different connection that happens that wasn't here for the last 6 months, we're able to flag that and determine what to do. Those can be automatic to say, hey, block that, don't let it occur. Or those are things that we can say, it's a connection to the OT, the outside world. We let somebody go in and program, that's okay. So we're going to allow that to happen. So it really helps with segmentation, helps doing that sort of thing. And also, what goes into that is industrial hardened firewalls. And this is where the Fortinet one comes in. For example, it's able to do deep packet inspection on things go through it. So it knows if it's Profibus, whether it's it's SIP or what types of protocols are there, and able to block reads, writes, downloads, those sort of things as well. So those are kind of top tier of the security environment. So example of an alert with Clarity is here's a configuration download that occurred, and it tells us that IP address that did it. And for example, it says the first time it's ever been done, we haven't seen that before. So we get a complete dashboard of events that happen all the time in the plant, which we would never know if we didn't have a software package to inspect those types of things that occur. Most hacks that happen in the OT or IT world, people are in there a year before anything actually happens. They're actually exploring the system, doing those sort of things. So this is where this is detected and determined. So kind of where that exists, firewalls are typically done a lot where they allow traffic to kind of go through and have block ports. IPS devices, like we just talked about, are able to inspect the traffic flow and do that sort of thing. And one example is, this is a device I just threw a picture of. It's a FortiGate 70F. And what I would do is put these on each of my separate cells in a plant, and that would divide traffic up. So I'm still able to talk to those devices through, it's essentially a firewall, but it's also doing the inspection of the traffic that goes through there and producing that map as well. So it's doing two things at once. So I get deep packet inspection of the traffic. I get the firewall capabilities that actually separate things out for the smaller domains and smaller areas of traffic as well. And this is one device, for example. Fortinet's a big company, has hundreds of other devices, but this is one, it's actually part of the Rockwell Compass program, for example, as a tool which they use to do this sort of thing as well. Okay, so that's real-time detection. And we're going to have another session next month that Fortinet's going to present on how that technology works, and it's going to be examples how that works together. What we'll find is, and this is an example of again, a Clarity, it's able to work with essentially all these types of systems that are out there. So if we sit down with IT and they're using any of these types of technologies, what a system like Clarity can do is say, okay, I can interface to a Fortinet and configure that device to be, what should be seen out in the system, for example. Okay, so next thing we have is a fairly low cost entry point of securing communications. Okay, when you talk to your bank, you know that you are always told to make sure there's an HTTPS for a secure socket communications to a bank or through work or anything else. And for some of us, that next layer is say we're going to add a VPN. And that VPN is going to encrypt communications. So not only do I have a secure socket, but I also have encrypted communications that is almost impossible for somebody to be in the middle and ever understand. Well, what SIP and through Open Device Net Vendors Association has is a secure protocol communications that can happen on that lower level. So, particularly in a new plant, in a greenfield plant, I would probably want to make sure this was in place. In an existing plant, not all old devices are capable of doing this. So there's some architecture might have to be in place to put some bridges and router type devices in between to make this occur. But what this does is lets me to have zones which are out there that communicate together. And the SIP protocol enables Ethernet IP connected devices to encrypt this. So when you think about a hacker, one of the things that happens in the OT world is they know that HMIs need to talk to PLCs, for example. So if they get in the middle of that, that's a good place to actually cause damage, to say, okay, we'll learn about what that HMI is doing and where it's changing variables and be able to go in there and do that. So what this secure communications would do is actually stop that from ever being able to occur. So it stops devices from being added to the system. It stops a device from being able to be put in the middle. It's what's called the man-in-the-middle attack, and having access that way. Now, the neat thing is it's kind of built into the system. So what it's able to do is if you have the right Ethernet cards, for example, and the right devices that are connected together, whether panel views or whatever else, this is something that's enabled with essentially a policy manager that's put in place to enable this to occur. And again, I don't want to go into all sorts of depth on this today, but keep in mind, this is a technology it's another one's kind of what I call low-hanging fruit to get things secure in a plant. So if I have this, take this step, eliminates a lot of access for hackers because they can't add themselves to the network. And at the same time, they can't get in the middle and listen to communications and see what's going on there as well. Okay, so with that said, The last thing we're going to mention, and there's a session on this we're going to do next month, which I'll cover too, is recovery and source code control. So Rockwell's had a product for a very long time, and it's called Asset Center. But what it's capable of doing is keeping track of devices that are in the plant, whether they're Rockwell third party, they could be, Acrobat documents, they could be Excel documents, anything that's out there, and keeping copies of those that are tucked away and secure and safe that I can access later. So when we look at this, we kind of through that threat detection, that sort of thing. So backup recovery is all part of this too, and being able to recover what's in there and return it back to an operating state. And what Asset Center does is it sits and monitors on a network, and it's capable of keeping track of archives that are out there for disaster recovery. It's capable of doing what's called audit. And what that does, it tracks user actions, and those could be HMI, whether they're an operator writing to a certain value and changing a value. It could be a programming change that's made, a force that's done in the controller for something like that. So we're able to audit what's been done. Security, it is able to be in place, and I talked a little bit about security earlier, where we can actually control who views things. There's a lifecycle management package, which actually goes out and scans and can see what devices are out there and where they're at in their life cycle, and do all these things together. So there's a session, 7:31. We're going to talk about that. We'll do an hour-long session on how Asset Center works and how it works with disaster recovery, for example, and you'll get an invitation for that if there's interest in that as well. And the last thing I wanted to kind of cover is there's a set of documents that are also good for all these technologies I just mentioned that include, essentially a link to those websites and where to download those, and a good place to start in your system as well. And you can download those yourself. If you have a problem finding them, let me know, and I'll help with the access to that too. So